Okay, welcome to video 2 here. We're going to be talking about simplifying radicals with variables. So it's the same thing we've already done. We're still going to use the VIPs list to break down the radical numbers with the largest perfect square. So you have to write down those VIPs just like we did before with, squaring every number so that we get the list of 4 and then 9 and 16 and so on, just like we did in the previous day. So you can copy that from your notes in the previous day. So use them to break down the radical number with the largest perfect square. But we have to simplify with variables now. Variable exponents must be even, and I talked about that a little bit. If you think about it, when we talk about like x times x, we get x squared. X squared times x squared, we get x to the fourth, because we always add the exponents when we multiply. So they're always going to be even. So here we have a to the fourth. Well, the square root of a to the fourth, remember that it's something times itself to give us a to the fourth. That has to be 2. A squared times a squared, add the exponents, does give us 4. So it's always half of the exponent. And then we look here, a to the 24th. Well, half of the 24, because remember we add the exponent, so it's got to be half of it. That's going to be a to the 12th. And then d to the 12th similarly must be d to the 6th. And when we have multiples under the square root, like e to the 6th and d to the 8th, we just take the square root of each of them separately. So the square root of e to the 6th is e to the 3rd, and then the square root of d to the 8th is d to the 4th. So we just write them side by side since they're both square roots. Now, if we instead have an odd number as the exponent, that just means we can't actually take the square root of that, so it would stay under the square root. Just like when we had like a radical 3 or something like that that we can't take the square root of, it just stayed under the radical. So what I want you to do, in addition to the VIPs that you already have written down, I want you to add the perfect squares for variables. So a squared, a to the 4th, because that would be 3, a to the 3rd plus times a to the 3rd. When you add them, you get a to the 6th. So you just keep going all the way down. So it would be a to the 2nd, a to the 4th, a to the 6th, a to the 8th, and so on. Or x if you prefer. Either way is fine. I just said a because that was what we had here. So I want you to practice simplifying. So 1/2, that just stays out front. The square root of 72, that's just an old one. So we would just take the square root of 72, find it on the list, just like we did the previous day, find where it falls, divide by the numbers, moving up the list until you find the biggest perfect square that goes into it. The only thing that's new here is the variables. Remember, we're looking for even exponents. That tells us that we can take the square root of it. Odd ones, we cannot take the square root of. In addition to that, you just need to keep in mind that just like before, we have the rules with exponents. When we multiply two exponents, we add them. And when we divide, we subtract the exponents. So those are the rules that'll still apply, and we can only multiply like. So like if it's x times y, it's just written as xy. Or x squared and y to the 4th, then they're written separately. Okay, that's it for this video. It's a very short one because there's not too much new information here, and you can just keep simplifying like you have already been doing. Have a good night.